Okay, so this is number 12 on the chapter 3 review. And so it gives us the function defined as f of x equals negative x minus h squared plus k. And the maximum point on the curve is 3, 2 here at point P. And so part A tells us to write the value of h and k. Oops. And the value of h would be the x value of P, so that would just be 3. Hold on. H equals 3. And then the value of k is just the y value, so that k equals 2. So show that f of x can be written as f of x equals negative x squared plus 6x minus 7. So now we use the formula that they gave us, f of x equals negative x minus h squared plus k, and we plug in our values of h and k. So f of x equals negative x minus 3 squared plus 2. And then when we simplify this, we get negative x squared minus 6x plus 9 plus 2, which simplifies to negative x squared plus 6x minus 7. Okay, so that is part B. And then for part C, sorry, I'm kind of running out of space, but it's just to find the derivative of this function right here.
10 minutes, guys. Use your time wisely.
And so that would be negative, so the equation for this, or for the derivative of this would be negative 2x plus 6. And that's part C. And now, on to part D. Okay, so now for part D, it says the point Q lies on the curve and has coordinates 4, 1. A straight line L through Q is perpendicular to the tangent at Q. Calculate the gradient of L for part 1. So D1, the gradient, if you remember earlier, we said that the derivative of f of x was negative 2x plus 6. So that means, so here the gradient here is negative 2. So that means that the gradient of L, which is perpendicular, would have a gradient that is the negative reciprocal of negative 2, which would be 1/2, positive 1/2. So that is the gradient of L. And then for part 2, find the equation of L. So we have the coordinates 4, 1. And so now we're going to write the equation using this 1/2 as our slope. And so using point slope form, we can say y minus 4 equals 1/2 times x minus, should be y minus 1 equals 1/2 times x minus 4. You can simplify that or leave it the way it is, either way, but I'm going to go ahead and simplify it because it's going to help me with the next part. So y equals 1/2 x minus 2 here, and then plus 1, which equals 1/2 x minus 1. So now for part 3, it says the line L intersects the curve again at R. Find the x-coordinate of R. So now we will set this equation, y equals 1/2 x minus 1. We'll set that equal to the original equation. So 1/2 x minus 1 equals, hold on, let me look at the original equation, be right back. Okay, so it equals negative x squared plus 6x minus 7, I believe. So if I simplify that, I get x squared minus 5.5x plus 6. And then if I go even further, I'm going to move this up here. I'm going to say x squared. Oh, and this equals 0. Oops. So x squared minus, I'm going to change this into an improper fraction. So if I multiply this whole thing by 2, I get 2x squared minus 11x plus 12. And I get rid of the denominator here. And now I can factor this. And so once I factor, eventually I'll get, Eventually I will get 2x minus 3 times x minus 4 equals 0. So x equals 3/2 or 4. But we already have, if we use 4, that would just be point Q, and we already have point Q. We're looking for a new point R. So since it's already used, we don't use the 4, and we just say that the x-coordinate of R is x equals 3/2. And that is number 12.